After this excellent talk by Dmitro, who spoke about internals, nitty-gritty internals of the Scala compiler, I would like to totally change the levels and go to, say, top level of Scala with the Scala Z and Cats libraries, which for me are nice boxes that have lots of interesting tools, which are patterns which we can use for us for programming. So you might have met those libraries. Who knows something about Scala, Z, or Cats? Hands up. Great. Now, those libraries are using category theory. This is some mathematical concept you might feel that's a bit alien, but I wouldn't like to touch that. I would like to talk in terms which every ordinary programmer, which I'm one of, understands. Okay? Now, a little comment. Scala Z and Cats might be very similar. So Cats might be treated as a modern rewrite of Scala Z. It's actually more a re-implementation of the concepts known from Scala Z in a more modular way, using more modern features present in the compiler. So a word about myself. I'm working at GFT Poland as a programmer, also as a lecturer at the University of Łódź. My education is, first and foremost, I'm a mathematician, so for me, category theory comes natural. But I have also experience as a computer programmer and DevOps admin, so I understand that it might not be natural to you. I've got a very mixed background, both in terms of technologies. I forgot about PHP here, but yes, I've programmed in PHP too. But I have Visual Basic here. Very varied domain, so and very varied experience. So like full stack. I've been doing DevOps. I've been doing containers in 90s, doing DevOps in 90s, and so on. So if you look at the fields which are arranged by purity, the mathematics comes in the end. Okay, so mathematicians tend to look down on everybody, but actually those guys to the left have their say. They want to say something very important, and this is something which is very important for me in programming, because in programming, we are first and foremost solving the grounding problem. So how our concepts we are using in our programs, which are logic, are relating to the world we are trying to implement. Okay, and good abstractions are most vital for both, and abstractions always leak. Okay, so there's no one suitable abstraction for everyone. You need to have your own abstractions. And also, I find debugging is a very important underrated skill. Okay, so why Scala? It's exactly because of that. I love Scala because it allows to build bespoke abstractions that fit your particular solution. It's more like a human language, and in Scala you're growing DSLs to match your problems, okay? So right abstractions are helping you to adapt to changing environment easily, and it's also very important, as well as that the code is dense and meaningful, then you can understand actually Scala program, and you can read the whole system, okay? So if you have a big system in Java, you have thousands of lines of code, and only IntelliJ can save you there, okay? But in Scala you can read the whole program. Scala blends seamlessly various paradigms, so if you need something from a separate toolbox, it is there, and you can use it. Scala has this quality without name, okay? So you know when you see it that Scala is really excellent, okay? So living with Scala, there's a bit of pain there, okay, in living in Scala. The dynamic ecosystem, tools change rapidly. The talk by Dmitro, the coming Dotty compiler, might completely change your programs, break your programs. My Sabin, this is just thing that is, it's developing as we see it. Is solved in all the issue. Seems he's solved that. SI2712. It will change many programs and it will break some of them. The libraries are changing. Many might remember the change from Slick 2 to Slick 3. Okay, Scala is now being. It's not exactly, okay, Scala is a very rock-solid library. I've used it in production code. But now the most development is happening in Cats, and you might feel that you will need to transfer your programs from Scala Z to Cats. soon. Okay, so right abstractions are really helping with that. So for instance, when I was working with a code, I was in Slick 2, I didn't work exactly with Slick. I was working with transaction abstraction, okay? Because Scala can take functions as first-class citizens. I create a with transaction. That's actually a wrapper. I wrap it around my function. It depends. I choose well, everyone has their notions. Whether it returns an EVA or an option or it's just a code block, it might return unit, so nothing actually. It might do something to exceptions that arise or not, transform them. It might be a free monad or an EFF monad, whatever you want. It will fit your abstraction, okay, and then it will work. Plus, Scala has an excellent, vibrant community. So, for instance, if you want to know more about cats, just join the Gitter channel, type level cats. Lots of people are there, very helpful. I would like to thank Pelquist for his help when I was preparing this talk, okay? Now, interesting thing about Scala is when you look at Scala, it also happens when you look at C++. When you look at Scala, is more acute. Okay, this is a toolbox of a woodworker, someone who works with wood, okay? Now, what are all those chisels for? Okay, beginner won't know. Professional will be using them to his advantage, yeah? And the problem with Scala is it's a tool for professionals, so you have long learning before you, okay? And there is this thing as Dunning-Kruger effect that the beginners don't understand that. So many people scorn Scala. And also, this is the same with those libraries, Scalaz and Cats. You might think, I don't need those tools because they look alien to me and that they look difficult to use. But it's not the case. They give them a try. These are nice tools somewhere to the right in this picture, okay? Now, I've talked about my background, and I would like to share with you how I see those libraries, okay? Do you know what's that? Oh, town square, yeah. And is it? A town square, very interesting. It's also a town square. No, not exactly, okay, because they run a street exactly through the city center, but still, all right? So there's a pattern there, okay, which you know has a name, a town square, okay? And design patterns, which you might know from the Gang of Four book or Java or something, but actually they originated from architecture, not IT. And there is a couple of books by a great architect, Christopher Alexander, okay, who wrote about patterns, yeah? The quality without name in the timeless way of building and design patterns, yes? What are the patterns? And in pattern languages, in pattern language, he defined a couple of those patterns, like, for instance, local town hall, yeah? A town needs a town hall, okay? A small public squares. Small public squares are needed by the community to thrive, and so on, okay? And these inspired people in IT at the Uppsala conference in '91, and then the pattern movement, like Pattern Languages of Programming, a series of excellent books that have lots of patterns that are not about object-oriented programming, but about architecture and structuring your code. So like patterns like reactor, proactor, half-sync, half-async. Future is actually implementation of one of those patterns, okay? So when I'm looking at things, okay, I'm looking from the patterns angle because I went through so many syntaxes, so many languages that I'm not looking at syntax. I'm looking at a general shape. Okay. Now I would like to start talking about those libraries from syntax extensions. Okay, two nice syntax extensions: show and EQ. EQ is those three equals. You might know it from Scala test library, but it's not that one. It's a bit different. Okay, works similarly. And show is a very interesting thing, a very interesting pattern. Okay, there are much more syntax helpers in those libraries. For instance, order. Okay, just check the documentation. All right. So for Scalaz is a monolithic library. It's a bit old. So you just do those two imports in that order. Don't mix the order, and you'll be fine. Okay, no need to import anything else. Can cause name clashes and general slowness, okay, because it allows lots of implicits, okay, and resolving implicits costs. All right. Scala Cats tries to be a more modular library. So for instance, if you want to use show, import cats syntax show, and maybe it's going to show you a couple of things, okay? But the code for cats and Scala Z is the same, modulo the import, okay? So if you remove the import, it will work in Scalaz. Very interesting for portability reasons, okay? What does it do? Nothing, okay? So ABC show is something that's able to show ABC, and 10 show shows us 10. Weird, okay? I have toString, okay? I'm a Java programmer, I love my toString, all right? But say I've introduced the class foo, all right? It's a nice class, foo, all right? And I'm printing this class. Not very meaningful, okay? There's just accidental complexity. Something happened by accident, all right? So custom class will not show by default, okay? This will be a compiler error, okay? This won't compile because that's an accident, right? Don't want accidents in my code, especially production one, okay? We need to inject show into foo using the show type class, okay? You know what type class already is if you've been to the morning talks. And so I need to create an instance of the type class, okay? So every type class needs an instance. Doesn't happen by magic. Otherwise, might be difficult to program in Scala, all right? So I'm having here an implicit that will actually add show to foo. It's just foo as, so just very simple thing. And it will just show foo. Right. Same code for Scalaz minus the import, okay? Works in Scalaz. Great. Now, if we have a toString, by example, defined in foo, now we can use it, right? So show from string is just an adapter, all right? Foo. Now, this code is cat specific. Whoa, interesting. But in Scala Z, just remove the import and use show from toString. That's going to work, okay? Now, you might notice that many of those enhancements in type classes is just pure syntax. You're just putting a syntax in a context, and you will be right, right? Because, yeah, there's a magic, of course, and the magic is that you've seen that int and string, they didn't require show type class, okay? Because they are already defined. So, for instance, for option, most operations are in option instances. If you're looking for an operation in both Cats and Scala Z, go looking for something instances, something syntax, and something ops, okay? Just browse the code base, all right? Mechanics in both libraries are similar. There is a manual on type classes for Cats that's going to help you on where to look. The Scala doc is not very helpful because of all those category theory thingy, which tends to inflate the types. But just go looking into the source or try finding a tutorial. All right, I have toString everywhere. Why bother? So moving some checks runtime to compile time. Okay, so show is moving something to compile time. Less risk of unexpected fail when deployed, especially important in production. We are using type system to help us, okay? So type system, this is the same thing as with shapeless. Why we're using shapeless? Because it does magic in compilation time. We are reducing cognitive load on readers of the code. If I use show, it's intentional, otherwise it won't compile, okay? No surprises at runtime. Very interesting, okay? And Scala is great, there's DI, AOP, whatever you call it, tooling, dependency injection, in terms of implicits and type classes, so we can use it easily, okay? Now, if you say this pattern seems weird, plain vanilla Scala does this in ordering T and ordered type classes, okay? So it's blessed by Odersky, obviously. And those two type classes have implicit conversions between them, and this is quite cool. This is the exact motivation, is also present in Java's interfaces, but the Java syntax is more limited, okay? Now, the EQ thing, okay, is just 3 equals, type aware check for equality inequality, will cause compiler error where types don't match. For cats, include the import below, obviously. For Scalas, no import. Use this one instead of the other one because it has precedence issues, okay? So this will compile, this will compile, this will compile for Scala Z, and this won't compile because the types don't match. false, true, true, as we expected, okay? Now, if we want to have for our foo class this in cats, this is a tricky thing because EQ type class, which we have to use, is defined in algebra, which actually implements algebra, but it's a completely external library. So this is modularity, okay? So you have to override this EQ, create an instance of the EQ type class, okay? And that's true. Scala is a bit easier. You have this equal type class, which you just override. But the structure is the same. If you look, those two libraries is not an accident, okay? Because that's the same pattern, okay? Now I'd like to talk about very important pattern, especially in big data, but also in streaming. We heard talks about streaming and big data, okay? Which is context and a functor, okay? Imagine you would like to separate functions that operate on certain types, okay? From the context and an environment in which they are run, okay? So, example, transformation of numbers into other numbers, right? Now, I would like to unit test this using Scala check. This is this randomized thing, checking, okay? Using a list, okay? But run in a distributed environment or run on a Spark cluster or something, right? Now, for unit testing your function, your function might be running in a context of a simple list, okay? But for real execution, it might be a stream, a future of list, list of future, whatever you take, Spark, DD, a reactive thingy, whatever is cool right now, okay? And you're getting the reusability of the code. It's even more than OO because you get the same code just in different context, okay? Cool. I want this pattern for my code, okay? Now, I know GeoF book. I see that's a common pattern enhanced with function object and a bit of iterator. Now, we call it simply Functor. Right. The essential thing for this pattern is the map function, okay? So interface satisfying requirements is a map function. Just map, okay? This in the context of the functor f, okay? Map this function f goes from A to B in the context of f. The implementation, for instance, is every generic collection that has a map function and takes functions going from A to B and returns this f, okay, from B, applying f to each element fa and building fb from results, okay? Right. I have it in standard Scala library, so what's the problem? Exactly as with toString, right? That's a map function from traversable-like, if you like. It does this building thing, okay? It has a builder, uses this weird can build from. I don't know what's that, right? So actually to use this for our custom type, lots of problems. Inherit from traversable-like, first of all. Implement suitable can build from, okay, for builder. Not that easy and requires a bit of knowledge around category theory, maybe. And traversable-like has a big interface. It has lots of different functions, and you would also have to implement them. All right. So I just want to factor out one abstraction. Okay. Treat this context map thing as a pattern. Factor out only parts connected with map, and I would have to define in abstract way this builder thingy. Yes, that I'm building this mapping in a context. All right. Can I do it? Yes, of course, with Scala Z and Cuts libraries. That's a functor. All right. Almost everything that has map can be converted to a functor. Relevant implicit conversion needs to be introduced. Okay. So these are my implicits. One of them is for options, the other is for lists. See, that's just a simple syntax thingy like with toString, okay? This is fa map f, okay? Not very much, but as in show type class, it's intentional. It shows you that there is an intention, okay? In Cuts, the conversions are in option ops and list ops. In Scala Z, option syntax and list syntax, because ops and syntax have opposite meanings in Cuts and Scala Z. And the method map itself is injected in both Scala Z and Cuts in instances, okay? Now you need the conversion to be in scope because that's a type class, okay? Instance of a type class, okay? Functor laws, okay? Not all collections are functors because I said this thing with builder, what's the abstract definition of this? Is that if I'm mapping with identity, I'm getting the same thing. And if I'm mapping with the composition of functions, that I'm getting the same as if I did a composition of those functions, okay? So if I do map f, map g, so the same as if I compose those functions, okay? So set, for instance, is not a true functor, and that's it's why it's in outlaws, okay? It's an outlaw, has to hide, okay? It's lawless type class, evil thing, all right? But you can use it just for syntax if you're careful, because not having laws is not a good thing for a society, right? Using functors. Now I can separate function from a context, and I can test my function separately from usage, okay? So, for instance, I can create this function transform with functor that takes implicit functor here, all right? And I can have my function twice, and I can transform list with twice, and I can transform option with twice, okay? This is a nice syntax extension that you get from Scala and Cats. Right, one sum, just nice thing, okay? Composing functors, okay? Now, we have the normal compose, which composes the functions that are mapped, but you can compose the functors in a bit different manner. I'll show you what's useful. It uses the scream operator from this picture of, it's called scream, yeah? This is in Cats code, okay? So I can have two functors, okay? Some 3 and some 5. And I can compose them, and then it's just something like Cartesian coordinates, okay? So I map this sum, which is aggregating. This is actually a reduce operation. So this has 2 coordinates, okay, 2 slots, and I can map this composite function, which expects 2 thingies, okay? Now, it's called Cartesian in Cats, okay? I have to import Cartesian to do it. And it's called apply in Scala Z. And this is called applicative builder, because scream is not a name, okay? Now, instead of map, we can use apply to, we have to use apply in Scala to apply to the apply to this, okay? So instead of map, I'm using the apply, because it's apply, okay? Right. And it's a type, it's a true type, so I can create a function build to, which has a type of Cartesian, or apply in Scala Z. That's just this. I just have to know what is the right name here, okay, to use it. Right. There's a nice thing, which is a functor with a constructor. Of course, the constructor is abstract, and it's called pure because of that, or sometimes point, okay? So applicative option pure 1 is just option of 1, and applicative list pure 1 is just list 1. Is a syntax abstraction to be able to create things separately injecting the type in which context is going to work, okay? To separate the type, okay, it builds the concept further. Why do I do it, okay? I had to use a custom thing because Cats 041 is the official build, doesn't contain applicatives yet, but you just can port it, okay? The same code works for Scala Z, but I have to replace map with apply, okay? That's a sequencer. It's just a list traversal, okay? Now, as you've seen in Shapeless presentation, list traversals can be pretty complex, but this one is rather simple, okay? So if my list of functors, okay, I'm transforming functors, list of functors into functor of a list. If it's nothing, I'm just using pure. If I can deconstruct it, I'm using x, and sequence this with a. I could make it more complex. I could add a separate function which I would be applying here, okay, or here, okay. So this would be something called traverse, okay. But I'm just using this, okay. And how to use applicatives, all right. This is interesting. I'm transforming a list of functors into a functor of a list. For instance, a list of Spark jobs into a Spark job of aggregate list. Okay, cool. A list of validations into aggregate validation. Cool, right? What happens with none? None is just short-circuiting and is killing our evaluation. Why? Okay, think about this example. Now you have this composition with none. How are you going to do the addition? Now you cannot do the addition because that's no argument, okay, and hence none, right? This makes sense. Now, applicative functions, for instance, can be used to read config files in a very nice way. So say you read a simple props file, getting a list of lines, one configuration is correct, the other is not, okay? So here I have a correct configuration which has a name, a password, and a DB name, okay? A username, and bad, it has just user and password, okay? Now, if I'm looking for the first property, I'm going to find it, and for other property in the bad config, I'm not going to find it, okay? So this happens in real life, okay? And now I can do read property, okay? I'm defining a read property, which is just reading a certain property. And now db props is just a Cartesian of those functors, actually applicatives, okay? Very clear, configuration reader, which extracts configs, okay? Remember about Scala's apply thing for applies, okay? Now, I'm just prop strings good, prop strings bad. I can read it, okay? Now, I wouldn't read it in real life. I would just apply it to the configuration in the database. I think it's cool. I've used it in production code, this pattern, okay? Applicative pattern configuration, I can do it in simpler way with sequence A, okay, which is the same thing, and get a list. And actually, I don't need to write sequence because it's in Scala and Cats. It's called traverse or sequence. Sequence is just traversing with identity. I could traverse it with 2 uppercase, for instance. So the first one is just sequence. The second one is traverse with identity. And the third thing is traverse with uppercase, okay? A very simple thing, okay? Now, what about validations? Can I use it for validations, okay? Because let's say I have 2 configs. One is bad and the other is very bad. You can use it also for web pages validations if you have forms, okay? None and none. Not very useful, okay? Right. Here comes another interesting pattern or tool in the Scala and Cats toolbox. It's called validated for Cats or validation for Scala. Now, these are abstract data types, okay? It's not exactly Scala syntax, but if you've just seen a Rabbit on Web's presentation or a blog entry by a colleague of mine, Marcin Kowalski from GFT, is just a ADT. So validated has 2 types, success type and failure type. One of them is valid and the other is invalid. And for Scala I have validation where I have success and failure, okay? So far, so good. But please note that the failure type can be a string, okay? So I can have a message there, okay? So read property v will just read this property, which will return the option, okay? I'm going to match the option, okay? In case it's none, I will say just this property was not found in config, okay? And return failure with this string, okay? Otherwise, I will return success with this very string, okay? And the helper functions is just the same. And now I can use the validation, okay? Traverse with identity or just sequence. Now you might notice that I have this U letter. Someone already spoke during this conference about the problem that if you have 2 types, okay, that the sequence, the type classes like the Scala compiler type inference won't work perfectly, so sequence won't work. So there's a special sequence U helper which helps with that. The apply props is just a very simple helper. It's just F, so it's just syntax, okay? And what do I get? Property, DB name not found in config, and the other 2 validations. You can use it for interactive forms to return all the invalid fields to the user, okay? You're just going through the form, looking which fields are not valid, and returning the IDs, which are then displayed by some tooling on the front end. In red boxes, you're hinting that the fields which are bad. Now, validated in Cats, there is a convenience method from option, which saves us this match, okay? So from option, and the result is pretty much the same, okay? Now, if you liked it, okay? If you think that's nice, if this it's not everything that is in Scalas, okay? I would have to go for hours and hours talking. So there's a bunch of nice conference talks from Scala's Exchange in London conference by Skills Matters. If you get a login there, you can watch those presentations. These are selected so that they match the topic. Especially this one is the same, but using Mooonads, okay, instead of applicatives. It's always discussion whether you use Mooonads, the other pattern in the toolbox, which matches the for comprehension, or the applicatives, which matches this applicative syntax of map. Okay, I personally prefer applicatives where possible. All right, and there's a couple of useful links for you. So there is this learning Scalaz and herding Cats. You can use learning Scalaz to learn Cats too. Obviously, there's a Cats docs, introduction to Cats, Cats versus Scalaz, post on Stack Overflow. There's Learn You a Haskell book, which actually would teach you a lot about this type class pattern and patterns connected with type classes and category theory. Plus the Scalaz for the rest of us, also useful for Cats, and the very interesting underscore book, Advanced Scala. Unfortunately, it costs a bit of money. This book is interesting because it has been transitioned from Scalaz to Cuts. Okay, I think the time is up. Many thanks. The slides are already in the internet. I've been beaming them from the internet. So thank you very much, and maybe